All right, so the chapter we're about to start has to deal with rational functions, and that word right now probably doesn't mean anything to you, except have you ever heard of a rational number?
Yes.
As opposed to an irrational number? Do y'all remember the difference?
No.
Okay, so a rational number is anything that you can rewrite as a fraction, more specifically a fraction of two integers. So like repeating decimals, like 0.3 repeating, you could write as 1/3. Pi, you can't do that. I know that you might have even read in a book, I've seen it in textbooks where even that orange Algebra 1 textbook y'all used, maybe in Miss Tyree's, it says, oh, you can approximate pi with 22/7. Not true. I mean, it's not even approximation, it's not even accurate to the third decimal place. So it's really, I don't know why people even say that, but an irrational number is something that can't be written as a fraction of two integers. So sometimes mathematicians, in this chapter they're doing it a lot, when they're talking about fractions, they just talk about rational expressions. So just know that when it mentions rational expressions or rational equations, they're talking about dealing with fractions, okay? So it could be something as simple as you just having to simplify, you know, I don't know, I'm making junk up right now. A rational expression, it might be a fraction and they're just asking you to go through the model of PEMDAS. It might be something like where they're asking you to add two fractions and you're finding common denominators. It might be something where they're asking you to solve an equation or you're dealing with fractions, and we're just going to go through these ideas. And yes, you're probably going to see some factoring in there, but the factoring that you see, at least on my test, will be very basic, trinomials, difference of squares. We're not going to get back into the ugliness. Now, occasionally it might show up on a homework problem, but if you understand the basic factoring, you're going to be in good shape. Now, if you don't understand the basic factoring, like there are a couple of rows on that test that you just took where it had some basic factoring problems, and most of you did a really great job on those, but some of you were still missing, getting the signs wrong. Remember, you got to be checking the FOIL. Once you get it factored, just quickly, first, outside, inside, last, check those numbers against your factoring process, make sure they're okay. But these are what we're referring to a lot in this chapter. So if you look at this first page in the book, and I think it's somewhere in the neighborhood of 103. All right, you'll see it says rational expressions of equations, and we're going to be simplifying these and going through the process of that. And you just got to be careful that you pick up on these rules and that some of your shortcuts are actual legitimate shortcuts. I think some people learn not by rules but by doing problems, and they just start noticing patterns and they get very comfortable with them. And then when the problem changes just a little bit, they get into trouble because their patterns don't fit that model. So as you're going through here, do a little of both. Make sure you understand the process. But anyway, when I said, what are we doing when we multiply and divide fractions? And how do we know the results are simplified? Just make sure that when you're looking at a problem at the very end, your integral coefficients are relatively prime. You know the word relatively prime? If you don't, a prime number is like 2, 3, 5, 7, numbers that don't have anyway, numbers that can be nice and simplified. Relatively prime means that they don't have a common factor. I guess it really doesn't matter about the prime because stuff like 9 is not a prime number, but 9 halves would be relatively prime because they don't share a common factor. Okay? And you can see 18 and 6, they are not relatively prime because they both share a 6. So you want to make sure that you have integral coefficients that are relatively prime, so that would clearly be simplified. Also, you want to make sure that each variable base only appears once in the fraction. So if I have a p in the numerator and a p in the denominator, I'm not finished simplifying. All right, it can be canceled further. Also, you don't want to have any powers of powers. You can see right here that b cubed is being raised to another power. Well, it's not simplified, then we're going to need to be able to address that. Also, something else, the way this book kind of processes, and most of the time you see it this way, when it comes to negative exponents, which you don't see any here on this line, but if you're going to have a negative exponent of the problem, if you're going to, like scientific notation sometimes has a times 10 to the negative 3. Well, that's a sign. If you're going to have a negative exponent, it has to be in the numerator, and every other exponent would have to be in the numerator also. You got with me on that? So bottom line, if you just get rid of negative exponents, just kind of deal with them and make them positive exponents through the rules that you're going to learn, you're probably better off than trying to leave them in there. But if you are going to have them, all right, then all your variables must be in the numerator. Okay? So you'll see kind of that play out as well. So what I want to do is just kind of go through, make sure, I think most of you are probably okay with the problems that I'm going to do. But when you're simplifying, ultimately, what are we doing when we're simplifying? PEMDAS. And you're going to find that PEMDAS will always get you there. It may not get you there the quickest method possible, but it's going to get you there. And practice is going to kind of give you a comfort level with taking shortcuts. So if I were to say simplify on something like this, do you see what you could do?
Yes.
So I can clearly divide 6 into 6 and 6 into 18. It leaves me a 3 and a 1. And let me show you an error I see all the time. People now, they go, oh, I can cancel 2 of those x's out. And I see them do this. They cancel the 2 x's out. Just what happened there? They cancel the x's out, and then they just write a 3 up there. And then, especially on really long problems where there's a lot going on, they come back later and they haven't really paid attention to what they've been doing. They go, oh, 3 times 3 is 9. And I see that kind of mistake a lot. So let me encourage you, when you cancel out a number, like divide a 6 in there and a 6 in there, write the number. But when you cancel out a variable, don't do stuff like this, because a lot of times you'll confuse it for a number. If you're going to listen, if you tend to make careless errors, just be aware of this. I do this. Cancel out the x squared, and you're left with 3 more x's. So just write x cubed. Are y'all seeing that? Now the math on that was this, and you learn this rule. If I ever have x to the, and you did it on this past test, remember how when you have like bases, what does the rule tell me? Keep the base, add the exponents. Well, if I have like bases and I'm dividing, the rule is keep the base, subtract the exponents. And then you have the choice. If I want to go m minus n, then leave it in the numerator. If I want to go n minus m, then leave it in the denominator. It's your call. So in this case, I had more x's on the top, so I'm going to go 5 minus 2 is 3, and I'm going to leave it in the numerator. Something like this, clearly I can cancel a 7. I can cancel one of those p's out. I'm going to put p cubed, because it's really easy for me to see what's left. I can cancel one of these q's out, and I'm left with a q cubed. And then now it's pretty easy for me to see what's left. And keep in mind, these are really basic problems. They're going to get longer. By the time you get to the end, you're going to forget what you've done if you're not really careful. That's why I completely rewrite the p and the q. What does PEMDAS tell me to do on number 3? It says what?
Right, like expand the
Parentheses? So can I do anything inside that parentheses?
not yet.
No. Then what? Exponents? So everything's getting cubed. Now if you want to write it out, if I'm cubing everything, I'm going 5 cubed, and then a cubed, and then b cubed cubed, and then you can come back and simplify 125a cubed b to the 9th, and then at this point nothing else simplifies. What about number 4? It says simplify, so what does PEMDAS tell you to do? Exponents, because there's nothing in that parentheses that I can simplify. So I'm going to raise everything to the 3rd. Now I'm going to cube a negative. What happens when you cube a negative? Does the negative go away or remain? Or you could say I'm cubing a negative 2. But I like to say 3 negatives is going to be a negative. 2 cubed is an 8. M cubed cubed is an m to the 9th. N cubed. And on the bottom, when I square everything, and now that I'm done with exponents, then I move to the multiplication and division part. So what can I cancel here? couple of those m's, 3 of those n's, and it's really easy for me to look back now and see what's left. I can see the stuff that is left. It's not going to get confusing to me. And I'm telling you, the biggest mistake I see is not understanding the math in this chapter, but it's getting lost in the problem because they have so much chicken scratch that they're writing and they can't read when they go back to look and put it all back together. Every year I see somebody do this, they just start canceling the 2, cancel the x, cancel the y's. Remember, stick to your order of operations, right? You got to do exponents first before you start dividing. So nothing in the numerator is going to cancel initially. 4x squared y to the 4th. Then come back. Cancel what cancels. All the x squareds, a couple of the y squareds. And then every year I see this as an answer. But it's really what? 1 over all of that. Because when you canceled, it was leaving 1s up here. Number 6. Exponents first. So I'm going to square all of that. And that gives me p to the 4th, 100k squared. Now, I have people all the time, they say cross cancel. I don't even know if that's a word. It technically is a phrase, but I don't even know if that's something you'll read in a math book. But let me just show you. When you're multiplying, now remember, it's when you're multiplying, not adding. When you're multiplying fractions, what are you supposed to do? Not cancel stuff. What are you doing when you multiply? What is?
Multiply the top together and multiply the denominators.
So you multiply numerators and you multiply denominators. So if I am multiplying, that's what I do. And then once I get to one fraction, because you notice that everything here is now one fraction and it's all multiplication, now I'm allowed to cancel if I see something cancel, right? Well, because of that, people look at this sometimes and go, oh, well then you can just cancel now because in the end, it's going to end up one big fraction anyway. And that's true, but only with what? Only with multiplication. That doesn't work with addition. That doesn't work with division. But only multiplication, because it's going to end up with one fraction, you're allowed to do that. So make sure you make a note of that. If I change this to a plus, it's a totally different process, right? Common denominators. If it's division, you're going to be flipping that one. So be careful about that kind of stuff. So right here, I can end up canceling the k squareds. 3 of those p's, the p left over, and that 5 and that 100, and I'm left with p over the 20. But please make a mental note, that is only when you're dealing with multiplication. People miss so many problems because of that. Now here's where stuff starts getting hairy and a little nasty to kind of pull from Tyree here. If I'm multiplying and dividing, what is your rule for multiplying like bases? You just said it. To multiply numbers that have like bases, you keep the base and add the exponents. There are a bunch of people on your test. I think it's the very first problem maybe, and it had something like 4 to the, I'm making something up, 3x over here, and then there was a 5 to the x there. And as y'all went into distributed, you went 20 to the 4x. But there's no rule like that, is there? The rule says you can't even multiply unless you have like bases, or unless you have the same exponents, and I have neither. So here, the only thing I could do there was just leave it. I don't know how to multiply that. I don't have any rules. So, but here I do have like bases. So initially, to multiply like bases, keep the base, add the exponents. And what do I get when I add the exponents?
0.
N plus 1 plus n minus 1. So the 1's cancel, but I get 2n. Now, on the denominator, what is my rule for dividing like bases? So I am going to keep the base and subtract the exponents. So what do I end up with? T to the n. I see a lot of people on this end up with t squared. Because they look up here and they go, why can't I cancel the n's out? Because I'm not saying 2n over n. I'm not doing that. I'm saying t to the 2n. So make sure you stick to your rules. To multiply like bases, keep the base, add the exponents. To divide like bases, keep the base, subtract the exponents. So with that in mind on number 8, and I have people every year that will leave this problem and go, I guess it's simplified. But remember, one of my rules was at the very beginning, you never want to have the same base more than once. So since I have x's more than once and y's more than once, I need to clean that up. So how do I approach it here? Does it look like I have more x's on the top or the bottom? The top? Okay, so then I'm going to go leave the x there and keep the base, subtract those exponents. Where does it look like I have the most y's? So I'm going to keep the y there and subtract the exponent. And then you can see the ends cancel on both of these, and I'm left with x to the first over y to the first. All right, a couple quick reviews of negative exponents. Does everybody know in here that when you raise a number to the 0 power that you get 1? That is true on everything but 0. 0 to the 0 is undefined. All right? So you might want to just make a mental note of that, but you can't say 0 to 0, but anything else to the 0 is 1. And then do you all know that if you ever have a negative exponent, all right, if you have a negative exponent, you can take that a and flip it into a fraction and make it a positive exponent. And if you have a positive exponent, you can flip it and make it a negative exponent. Most people don't want negative exponents. So most people take a to the negative ends in the denominator and make them a to the positive ends in the numerator. Or a to the negative ends in the numerator and make it a to the positive ends in the denominator. Because usually you're trying to get rid of those negative exponents. So how can I rewrite this?
1 over 100.
So 1 over 10 squared, which simplifies to 1 over 100. What about this?
1 over x to the 4th.
1 over x to the 4th, great. What about that? Now be careful. What is being raised to the negative 4 power? The negative or the negative x or just the x?
Negative x.
A lot of people think negative x. Let me show you something. That's not right. Check it out. This is the negative 2 squared. Y'all with me? So that's 4. This, believe it or not, is negative 2 to the 4th. That's negative 4. Now, a lot of people go, I don't buy that a bit. Okay, hold on to this. What if I were to say negative x squared? Would you turn that into x squared?
Yeah.
You would?
I mean, no.
Okay. What if I had negative 4x squared? Would you change that to 16x squared? No. You wouldn't change that to 16x squared. And that negative 4 is very similar to just a negative 1, isn't it? You follow me? Like, people wouldn't change that or that, but then when they see this, they go, oh. And when they see this, they go, oh, the 2 must be with everything. No, the 2 is just with the number it's touching. So if it's touching it with a fraction, with the parentheses, then yeah, everything in the parentheses goes with it. But if there's not a parentheses, it's just with the number it's touching. It's important that you see that here, because I'm going to really test your knowledge of that. So right here, what is that negative 4 touching? Just the x. So leave it with just the x. Just think about it like this. Leave the negative out front, and what is the x to the negative 4? 1 over x to the 4th. So that 4 doesn't change that to a positive, does it? Y'all seeing that? It's really important that you see that. That's a problem that I think a lot of my students come in with every year. They don't make that connection. All right, what about 12? 10 to the negative 2 times 10 to the negative 6. What do our rules tell me? So how do I multiply like bases?
Keep the base.
Keep the base. Don't make it 100. Make it, keep the base. Add the exponents. 10 to the negative 8. And that kind of stuff sometimes shows up when you're dealing with scientific notation. Now, number 13, I'm asking you to multiply here, but I got all kinds of junk going on. Is there anything that's kind of bothering you initially? Like if you had to say there's one thing bothering me on 13, what would it be?
The negative exponent on the bottom.
The negative exponent on the bottom, the negative on the top, is not bothering you?
I don't like this, a negative or a positive y squared, and then on the y to the negative 30, so I would cancel those out. Okay.
He actually brought up an interesting point. I'm going to use a different fraction, but a lot of people do make this mistake. They look at this and they go, oh, I can cancel 2 of those y's out. What would you have left? Y to the negative 2 maybe? Guess what that's equal to? That's y to the negative 6. Or y to the 6 in the denominator. If you use your rules. But I think a lot of people have issues with this. So here's my piece of advice for you. When you see a negative exponent, my advice is turn it into a positive exponent, and then your brain thinks a little bit more comfortably. Now, I'll show you both ways. But change it to a positive exponent, I think you're going to be happier. Now, technically, here's the math of this. And you're not going to like what I'm writing here, but I'm going to show you, and then I'm going to show you a better way to do this. Technically, here's the math. X to the negative 2 is 1 over x squared. Bring over the y squared. Okay, now I'm going to show you a better way, so don't copy this down. Or if you can if you want. Y to the negative 3 is 1 over y cubed. X to the negative 4 is 1 over x to the 4th. Now that's technically what you have. And if I were to multiply this, and then I'm going to show you what you're going to end up with in a second. If I were to multiply this, this is going to give me, putting it over here, 3 over x squared divided by a y squared. Right? And to divide by a y squared, what do I really do? Multiply by a reciprocal. And that gives me 3 over x squared y squared. So this right here gives me 3 over x squared y squared. Now what does it look like I did to go from here straight to there? So I just took the x to the negative 2 in the numerator, made an x squared in the denominator. Can I always do that, or can I only do it when I am multiplying and dividing? The second one. Okay? A lot of people don't recognize that, and they make the mistake of when you start seeing addition in there, they go, oh, if it's addition, you can just move it to the bottom. No, the rule is I can flip it right where it is. But if you're only multiplying, then you can slide it down, or this one slide it up, if you're only multiplying and dividing. So I'm going to skip all this junk, and I'm going to go straight to, that is, leave the 3 and the y squared alone, slide that down. And it looks better already. Now, to this right here, if I was going to clean up that second part, same thing. I don't need to write it like this and think through it. What can I do to this initial fraction? Leave the 4 and the x where they are. Because it's all multiplication or division, I can take that y to the negative 3, move it down. X to the negative 4, move it up. And now I'm more comfortable with it. I feel a lot better about my canceling. I can come in here and say, all right, I can cancel 2 of these x's with 2 of those x's, and I don't see anything else that cancels, so what am I left with? 12 x cubed over y to the 5th. But the second I start seeing addition in there, can't do it. All right, what about 13? I'm checking your knowledge again. I'm sorry, 14, not 13. Number 14. Is negative 3 to the negative 2? Is that negative 2 with the whole negative 3? No. So what can I do with that 3 to the negative 2? Make it a what? A 3 squared in the denominator? Leave the negative out front? So at this point, I just have negative 8/9, right? A lot of people see that and they take the whole negative 3 on the bottom and they square it and end up with a positive 8/9. Now look at number 15. Kind of brings the point home. Number 15 and number 14 were really the same problem except for the parentheses. So now what happens on 15? Yeah, the whole thing gets brought down to the denominator and squared. The 2 cubed remains in the numerator. And this time I do end up with 8/9. What about 16? That's pretty nasty, huh? Let's stick with PEMDAS. Okay, so that 5 is raised to the negative 1, so that's a 1 over 5 to the 1, but it didn't affect the negative. Now, what does this say?
Switch it back.
So a lot of different ways you can go here. Yeah. The negative part says put it back up in the numerator. Well, it technically also means that everything is getting raised to the negative 2 power. Guys, if you ever see a negative exponent on an entire problem like this, it basically means to flip it. Now put that on number 17. So part of me wants to look at this and go, wait, if this whole fraction is being raised to the negative and then squared, then I'm just going to flip it into a negative 5, and that takes care of the negative part, and then I can square it and get a 25. And feel a lot better about it. Are y'all seeing that? So yes, over here, that is true. You can always flip something right where it is to deal with the negative part, and then you can come back later and deal with the m. What about 18? What would you do first? Got to deal with exponents. You can't just start canceling right now. Don't go backwards on PEMDAS. You've got to deal with exponents first before you start dividing. So, real quickly, what do you get?
64 x to the negative 6 plus 110 c squared.
Good. And then on the bottom, 4.
4 x to the 6 y to the 4th c.
And it's so important, guys, that you don't take this x to the negative 3 and move it to the denominator. Don't do that before you deal with the power, okay? Because it's not an x to the negative 3, it's an x to the negative 6. And now, do I really even need to move those x's? If they're exactly the same, why not just go and get rid of them? And then I can cancel all kinds of stuff here. And again, if you're writing everything below and you're keeping the z's on there, when you're finished canceling and you go back and look at it, it's really clear what I have left in this problem. Also, let me make a point. A lot of you guys I've seen on the tests, like when you cancel something, you scribble it out. Imagine if I did this. Every time I scribbled something out, if I do this, and then you're wrong, I have nothing to see. So when I'm grading your work, I just see a bunch of darkness and a wrong answer. So try to just lightly cancel stuff so that I can still see what you're doing and give partial credit as much as I can. What about 19?
Well, can you flip the whole thing? Make that.
Now, here's two options. The whole thing is not being raised to that negative 2, but those are negatives also. So one option would be to take that whole parentheses, move it to the bottom, and make it a positive 2, and then make both of those positive exponents on the top. And I can do that because I'm only multiplying and dividing, right? And then I could go about my business and square the bottom. This is option 1. And then I can cancel some a's out. So if you got b cubed over 9a cubed, you're in pretty good shape. Now here's option 2. Another thing you could do is literally raise everything to the negative 2 power. Isn't that a rule? You have parentheses raised to a power, just raise everything to that power. So here we go. I'm going to raise 3 to the negative 2. I'm not going to simplify it. I'm just going to write it. A cubed to the negative 2. What's the rule on power to a power? So multiply a to the negative 6. And then you have this. Now what can you do?
Cancel.
Well, hold on. I have rules for canceling when they're positive.
Oh.
But I don't have comfortable rules when they're negative. Now I could use my rules and say, like bases, keep the base and subtract the exponents. I can do that, but we already have a comfort level with positives, right? Positive exponents. So make them positive exponents. 3 squared comes down, a to the negative 6 comes down, a to the negative 3 goes up, b to the negative 3 goes up, and now I'm in the same spot I was right here, other than the 9 not being simplified. So you've got a couple of options on that. You get however you feel comfortable, start doing that. What about number 20? What can I do with that negative 1? Flip it. We got a rule on that, right? So if I flip that, the y ends up in the numerator, x squared in the denominator. Now it's raised to the positive 1, which is done. And then here, power to a power, square everything, and then cancel what you can. And again, when you cancel, don't end up with y cubed here. It's what? 1 over the y cubed. All right, what about 21? So what's in parentheses? All of that is being raised to the negative 2. So if I want, but this 2 is okay, right? Nothing wrong with that 2. So one thing I could do is leave this 2 where it is, and I could take that whole thing right there, move it to the bottom. This is just one option. Now that's squared. And I could take the y to the negative 1, move it to the top, make that a positive exponent. Did y'all just see what I did?
Yes.
Now, do you think that's the most efficient way to go about this? I don't think. But I'm going to stick with it. Now what would you do?
Exponents.
So, power to a power, multiply. Drop the 2 down. And when I square this, that 2 now becomes a 4. And then when I square the negative 1, power to a power, multiply. But I still have negative exponents. So then I would, because it's all multiplication and division, I can move the y squared to the denominator along with that 8. The x to the negative 2 I can move to the numerator. And that is one way to do this. It's not what I would have done though. This is what I would have done. Because I see all these negative exponents, check it out. 2 to the negative 2 power. I'm not going to simplify that. I'm just going to write it like that for now. What's x to the negative 1 to the negative 2 power? X squared. Oh, no negative exponent. That's fine. Leave the 2 alone. What's y to the negative 1 to the negative 2 power? Well, that looks better already. And all I have to do now is take the 2 to the negative 2 and move it down to the denominator with the regular 2, leaving the x squared and the y squared alone, and there's my 8 on the bottom. So if you happen to look at it and see, hey, power to a power, if I just multiplied the powers, those negatives are gone, I'm only left with one negative exponent to deal with, great. But don't call 2 to the negative 2 negative 4. Don't do that. Negative exponents, dude, are they ever going to make you have a negative number? No, think about it. 3 to the negative 1, it doesn't make it negative, it just makes it smaller. 5 to the negative 2 doesn't make it negative, it just makes it smaller. It just flips it. Are y'all with me? Doesn't make it negative. So 2 options to get to the same place. And there's more than that if I really want to play around. What about this?
First one's a 1.
Okay, so first of all, the a to the 0 is a 1. And what would I do with a parentheses 1 over b to the negative 2 power? Would make it b squared, because the negative part flips it into a b, and then all you have is the 2 part left. What do you want to do on this second part? You have multiple options.
Flip inside the parentheses first.
Okay, so if I flip first to deal with that negative, that gives me this. b the negative 2 comes up, a goes down, but that negative on the outside goes away. This is one option. Then what would you do? Square everything, power to a power, multiply the powers, a squared in the bottom, and then finally what do you do now?
Flip.
Now I could bring the b to the 4th down, and then I could cancel a couple of those b's. Y'all with me? So I cancel a couple of those b's out, and I get 1 over a squared b squared. Now can y'all think of maybe a better thing I could have done from the very beginning?
Just done a to the negative 2 or b to the 4.
Okay, that's one option. I could, and I kind of like that better than what we did. He's saying, as opposed to flipping it, just raise everything to that power. And that gives me b to the positive 4. And then all I have to do now is drop the a squared down to get to here, right? Anybody see something else I could have done? What about just bring that b to the negative 2 up before you even get started on this problem? And then I could look at this and say, oh, the negative part flips it. and then I could just square it from there. Right there, square the bottom. Deal with this. Go from there. But a lot of different ways you can do it. But show me your steps, show me your work, so if you make a mistake, I can see what you did wrong. Now here's something I see out of people a lot. Actually, maybe not of this one so much, but what do I do with 23? And what's different about 23 than every other one I've done?
It's addition.
Suddenly you see addition. And what are our rules for adding fractions? You find a common denominator. And what is a common denominator essentially? What math are you doing to find common denominators? More specifically, close. It's the what? The LCM. You're finding the least common multiple. Now technically a common denominator is just a common multiple, but the least common multiple is going to make your life a lot easier in the long run. So when it comes down to adding these, I got to make sure I have a common denominator. But in the meantime, I can go ahead and just do the PEMDAS, right? Anything in parentheses? No. Any exponent work? Yes. U to the fourth over V squared. Now what would you do with this? Is that negative 2 exponent on the U or the negative U?
The U.
The U. So this part that I'm circling has nothing but multiplication, right? I know there's a minus, but that's not subtraction right now. That's just a negative, that times that. So right there, if I want, I can leave that negative out front, leave the V in the numerator, bring that U down. This is one option. Then what could I do? Flip it. That gives me still a negative. Now I have a U squared over a V and a positive exponent. Then what? Now squaring it makes it positive. So I really don't need those parentheses now. And I actually do have a common denominator. So what do you end up with when you add these? 2U to the fourth over that common denominator of V squared. Can anybody see a better way they could have done that? A little less work. Say it again.
Just not flip it.
Not flip it and just do the exponents? So let me ask you a question. When you square everything, you're squaring everything with a negative 2. What do you think that does? You're squaring it and flipping it is what that negative means. What do you think that's going to do to this negative sign? It's going to make it positive. Do you see that? Remember, that's just like squaring it with a flip included. Square flip. You're still squaring it. And when you square a negative, it's going to make it positive. So here's what I would do. I would square it, which makes it positive. Then I would go power to a power. Power to a power. And at that point, it'd be really easy to say, oh, I just got to move that V down now. And I saved an extra step. I can cut that out. Not too bad. Sure, not too big. All right, last thing. Is this true? And this is such a big mistake I see over and over. I mean, it looks true, right? Because we know that this is true, isn't it? Is that true? No, that's not true. Is this true? That is true. Is this true? That's true. If you're only dividing and multiplying, you're raising everything to the power, raise everything in there to a power. When you are adding and subtracting, that is not true. You know that because we spent a whole section on doing expansion, like binomial expansion with Pascal's triangle. When I square stuff, do I get this? A couple of you tried to do that on the test. Do I get that? No, I always get that middle term, don't I? The 2 row, 1, 2, 1. If I'm cubing 1, 3, 3, 1, Pascal's triangle. So this is not true here. Well, it is no way it's true there. What would you have to do to simplify something like this? the whole thing gets raised to the positive 1 power. So it's just basically 1 over x plus y. Now that's different than this, isn't it? What is this telling you to do? Remember, if it's addition subtraction, what do? You don't do this and go, oh, move the x to the bottom, move the y to the bottom. That only works when it's multiplication. If it's addition subtraction, you flip it right where it is, right on the spot. That's a 1 over x. That's a 1 over y. So if you ever see an addition subtraction mixed in there, just make it a reciprocal. If it's multiplication, then yes, you can move it to the denominator. Does this end up giving me that?
Yes.
Does it?
No.
No, because here to add these, what would you have to do?
You would have to find the
Common denominator, right? You're going to end up with y plus x over xy, which is totally different than this. Y'all seeing that?
Yep.
I think I even gave a test question last year that looked like this. I said something, or this was part of it. And I saw tons of people that went, oh, that's the same thing as x cubed plus y cubed. But that's not true, is it? What's the rule when there's addition or subtraction in there? Flip it right where it is. And then find a common denominator if you have to. All right? All right, do that homework, see what you can do.